Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 27 of our 30 LeetCode challenge, and the problem that has been given to us today is the maximal square problem. Again, if you want to try solving this problem on your own, you can pause this video and check out the LeetCode link given in the description below. And let's just dive right in. So the problem statement is that you've been given a 2D binary matrix filled with zeros and ones, and you need to find the largest square containing only ones and return its area. So you've been given an example over here where you have a 2D matrix, and you can see that the values which have been highlighted in red basically form the largest square. And the property that you need to abide to is that a square should have nothing but ones. And you need to return this area, so the area for this square should be 4, and that's basically the output. So I remember like when I had solved this problem, or when I had actually looked at this problem for the first time, I was thinking of more like a DFS approach, and you could probably sort of solve it using that, but this problem is uh, mostly a dynamic programming problem. And today we're going to solve this problem using nothing but dynamic programming. So before we do that, we need to analyze how we can use dynamic programming in order for us to solve this problem. And we're going to preset this thing in our mind that we need to solve this using DP. So one thing that we can note is that we can sort of break down this problem and make it a lot more easier. So how do we make this easier? Well, a common property of a square would just be that the area of a square is basically L square. So the length should be basically the same. So as you can see over here, this length and this length is exactly the same, which is 2, and you're doing 2 into 2, which is 4. So if we can form a logic behind finding the same length, we can ideally, make our entire logic revolve around that. So that's one intuition that we can use. And the other intuition that we can use is that we actually know that when we look at this particular value, let's look at the last value inside a square, we know for a fact that this can only become a square if all the values are ones, or in better terms, if all the values are equal to each other as well. That's sort of difficult to understand, but when you draw it out, you'll also get the same sense of it. So if you have 1, 1, 1 over here and 1, 1 over here, basically you'll have nothing but ones, which is pretty obvious, and that will be a bigger square. But the property that it can sort of use is that all the values that you have when you start with this index or this index, well, at that point you have everything is the same element, and you can use that in a dynamic programming way to solve this problem. So we're going to try coding this thing out, and then things are going to become a lot more easier. So we're going to start with the base condition, which is just going to be, if nothing has been given to us, then we return a 0. And we're going to be using a DP matrix, and I'm just going to make this a simple call where I just convert everything. And before I do my conversion, do note over here that the matrix which has been given to us, which is our 2D matrix, has a list of lists and all the elements are string. So we need to convert those into integers so that we can perform mathematical operations inside of it. So I'm basically doing a copy of our matrix inside our DP 2D matrix, but the only difference would be, for now, would be that it has integers instead of strings. And that's pretty straightforward to do. You can use map, pass in the int function, and pass it the row, and this should ideally convert everything. So let's do a quick print, and hopefully we can get something out. So let's just run this thing. So let's see whether we're getting the correct this thing, and we are. So we are good to go on that front. And now all we need to do is we need to iterate through each element inside our matrix and look for the previous values which were there inside our DP as well. And we've already established that the result that we're going to have is going to be the maximum length that we found so far. And then we're just going to square it up. So we can just say result is going to be equal to 0, and eventually what we're going to do is we're just going to result into power of 2, so result square. And now what we need to do is we just need to do an iteration for all the values from all the rows to all the columns, basically get all the elements. And let's just quickly do that. And this is where we just need to, stop for a minute and just think about how a dynamic programming problem is going to run. So again, we're going to be using length. That's one of the more fundamental things. And the second thing is that we need to know that all the values that we have, for example, if we take this value um, and we call this I comma j, basically I minus 1 comma j should be same to I minus 1 comma j minus 1 and I comma j minus 1. Or rather, what you can do is you can sort of fetch the minimum value and append it accordingly. So in other terms, what you can do is you can check for dpij and check whether it's a 1. If it is a 1, actually let's use matrix because that's our main guy. Let's use matrix over here. Let's convert this as 1. Right. So if we encounter a 1, well, in that case, we need to update our dpi comma j. So we'll just say dpi j is going to be equal to 1, which we have already established before, plus the minimum value that we can form with dpi minus 1 j versus dpi minus 1 j minus 1 and dpi and j minus 1. So do note over here that the way this is going to work is that your DPI is going to get updated whenever it encounters a 1, and whenever it encounters a 1, it tries to fetch the next value. So if you look at this example over here, this value is going to be equal to 2, and that's what we want. And one more thing that we should note is that, I mean, you can just do this through your hand. You can just, write it down. You can see that dpi minus 1 is 1 over here, same over here, and same over here. And the minimum of all ones is just going to be 1 as well. So you're just doing 1 plus 1, and you're good to go. And eventually, as you know, you're just going to have to return it. So just update the result as well. So we're just going to update it with whichever value is maximum, dpi comma j, or result. And basically that's it. So let's just go ahead and run this, and hopefully this should run for at least this use case, and then we can try to break it down and see whether it would run for everything else as well. So even though we've sort of built out our logic, there are a few problems with it. And if I think about it, the first problem that we're going to get is we're going to get an error because you're doing dpi minus 1, and same thing over here, and you're basically starting from 0, so maybe that's something that we can avoid, but it's not really that necessary, to be honest with you. And it's just preferences. So you can do if matrix I comma j is equal to 1 and I and j, so basically whether they are non-zeros. So if you run this, hopefully this would also run fine. There should not be any issues with it, and you can see it is running fine. What I want to focus on is if we convert this and make this bigger and we use this array, now you can see that um, this columns from 0 to 2, index from 0 to 2, and rows indexed from 0 to 2 are basically going to be our major or our biggest square. And the way we can look at this is we have all the ones which are fine. We can look for values which are on top, which we're not going to find. And when we come over here, what's going to happen is that we're going to have 1 plus the values, the minimum values which are there on a site. So this is going to become 2. Same thing over here. This is also going to become 2. And if you go down, this thing is also going to become 2. And when you come over here, you have a bunch of 2's, and then you just do 1 plus 2, which is 3. And that's basically the max that you can get so far. So this 3 symbolizes the length of all these guys. And I know it's a little tricky to understand, so I think it would work in those scenarios as well. So we're basically good to go on our end. We've also handled a few other conditions, and I'm just going to make this 1 comma everything else, and I'm just going to remove this because I don't think it's required. Hopefully this should still run fine, and it is. So let's just go ahead and submit the solution, and hopefully everything should run fine. Whoops, we are getting an error, and let's look at the error. So the error we're getting is the output which was returned was something else versus what we were expecting it to um, actually return. So a quick way of just taking this into consideration is if I can just remove this 1 comma 1 that we had added and add the same ing. So basically what's going to happen in that case is your result is going to get updated, and I think result is not getting updated, so that's what's breaking it. So let's just go ahead and run that, and yeah, you can see it's been accepted. So basically the trick over there was that you had to make sure that the result would also get updated. So there are multiple ways of doing that. You could basically check the length of the matrix and check whether there's any values which are ones inside the TP and sort of move forward with that. Or you could just run the same iteration, put in a few conditions so that you don't have index errors, and then you're just good to go. Cool. So that was it for today's video. If you have any comments or if you have any suggestions, do leave it in the comment section below. And if you did like this video, do give a like and do subscribe to our channel. We have discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. You all know it, and have an awesome day. Thank you.